Greetings everyone and welcome to this video on the non-parametric alternatives for Pearson's correlation, the Spearman's rank test and Kendall's rank test. In case an ordinal variable is skewed, that is non-normally distributed, these rank-based tests can be used, just like the Mann-Whitney test instead of the student's t-test, or Wilcoxon ranked sum test instead of the paired samples t-test, or the Kruskal-Wallis h-test or the Conover's-Post-hoc test for ANOVA, etc. This dataset provides participants creativity test scores and the rankings in a line competition. The creativity column indicates the creativity test score, this one, and the position column indicates the ranking achieved in the competition from 1 to 6. And this novice column indicates whether the participant is participating for the first time or not. We will test the adequacy of the null hypothesis, which states that creativity is uncorrelated to the rank in the line contest. So to do that, we can go to correlation analysis and do the analysis. You can display pairwise. We immediately see a p-value which is significant. However, we will first do an assumption check for normality. For pairwise normality, this is the Shapiro-Wilk test, and we immediately see that the p-value is significant. That is, the data is non-normally distributed. To see this clearly, we can get some descriptives for creativity and position. We can get some distribution plots, and we can see that the creativity scores are beautifully normally distributed approximately, but the position ranks are positively skewed and not normally distributed. So in this case, we cannot use the Pearson's parametric test with absolute certainty. Instead of that, we need to use rank based tests, and in this case they are Spearman's rho and Kendall's tau, so you can use either of them. We'll deselect the Pearson's R checkbox, and yeah, so here we get both of these p-values to be significant. We can get some scatter plots if you wish, and can order some statistics for the rho and tau values. So that's it for this video. Thanks for watching, and I'll see you in the next video.